So then the next thing is, how do we describe these three things? And there are specific terms that we use to describe numbers that go with each of them. So an observation or a score, right? So I think your book tends to use the phrase score, but an observation or score is a single numeric value that characterizes the unit of analysis on some given variable. So for example, if I'm talking about myself and height, then if I say 70 inches, for example, if we're going to use our standard, I think it's like 178 centimeters or something. I don't know. But that would be a score for my height, right? So that observation or score is a value, i.e. the number 70 inches is the unit that describes me on a variable, which is what? Height, right? And height is a variable because units of analysis can have different heights. So anything that can vary within a population of interest is a variable, right? Different individuals or units in the population can take different values, which makes it a variable. So that is how we describe a unit of analysis. Now, the number that we use, or the term we use for numbers that describe or characterize a sample, is statistic. Sometimes you hear the word estimate. You can use them synonymously, and that's all right. So a statistic then is a value that describes the entire group of people. And if you think about height as another example, imagine we got the heights of everyone in our class, and we put all those heights together, and then we divide by the number of people in our class. What we have just done is created the mean, the arithmetic mean of height. And so the arithmetic mean for height is a single value, right, that describes the group as a whole. So say that the mean height for our class came out to be 68.43 inches. I am not saying that everyone is 68.43 inches. In fact, there may not be a single person in the class that is 68.43 inches. The point is not for that value to describe every unit individually, but rather to describe all units collectively as a sample, right? When we use it as a descriptive statistic. More on that later. Okay, so that's a statistic or an estimate. It's a single numeric value that describes or characterizes an entire sample. Now, a parameter is a number or value that characterizes the entire population. Okay, now this value is almost always unknown, and often I would say it is unknowable. We can't know that truth, right? The truth of what is the average human height. You can't measure every human that ever has, will, or even currently lives to think that you could possibly get the average human height, right? And so some of these things are just impossible. You know, how many birds are currently flying in the sky? You can't know that. It's it's just an unknowable value, right? So there is a truth out there, but it is a truth that is unknowable. So we do the best we can to get after it. So a parameter is that value, often unknown, that characterizes or describes a population as a whole. So hopefully a little bit of alliteration can help you remember how these things go. Statistics go with samples, SS. Parameters go with population, PP. Yes, I just said PP on this lecture. All right, so hopefully you can remember some of these things and use the correct terms. It's important, right? They'll also be notated in different ways, right? So we'll talk about the notation for an observation, a statistic, parameter. They all have their own symbolic form, okay?